Hello everybody, this is Rudra Pradhan here and welcome you all to BMD lecture series. Today our discussion is inferential analytics and that to part 2. In the last unit we have already highlighted the inferential analytics part 1 and the idea behind the particular discussion was to solve some of the business problems relating to one sample case, and the structure of the inferential analytics is to draw the kind of conclusion behind the population parameters, and specifically we like to address three things. First, to know about the structure about the population parameters, that to check whether the structure of population parameters still valid or not valid by using some of the sample informations. And second thing is to know the confidence interval about the population parameter, and then to find out the optimum sample size. And specifically we have solved all these problems and discussed all these three issues relating to the comment on population parameter and the confidence interval about the population parameters and the optimum size of samples, and that too by using Z statistic, T statistics and chi-square statistics. And in this particular unit we will address all these problems and by using the kind of multivariate structures. So, that means in this particular inferential analytics, that is on part 2, we will solve some of the business problems relating to multivariate case. So, that means at least we must have two different samples or two different variables through which you have to draw the conclusions, and that to comment on the population parameters, and again the confidence interval about the population parameter and the optimum sample size. So, in fact, in this case we will address one more thing, that is on F statistic, which we have not covered in inferential analytics, because F statistic is typically multivariate kind of means it will be applied in a kind of multivariate situation. So, corresponding to this particular brief structure, so our typical objective is here to test hypothesis and construct confidence intervals about the difference in two population means, and using the Z statistics again to test the hypothesis and construct confidence interval about the difference in two population means by using the T statistics. And again we will solve some of the problems relating to categorical data and by using chi-square statistics, and then we will solve some of the problems by using F statistics. So, typically we are going to address T statistics, Z statistics, chi-square statistics and F statistics, and then we will apply those statistic in the situation where at least we have two sample case or multiple sample case. So, initially we start with two sample case, then we will extend to multiple sample case. So, before we start the process, I like to highlight that any kind of business analytics investigation or statistical investigations. So, the structure of testing with respect to one samples, two samples and multiple samples, that means univariate structure, bivariate structure and multivariate structure. In the univariate structure we must have one variables, and that to one sample through which you have to draw the conclusion about the population parameter and bring the confidence interval about the population parameter, and then we have to find out optimum sample size corresponding to a particular test statistics. And in the bivariate case you must have two samples, and then we like to know the difference about this maybe mean difference or variance difference corresponding to two samples, and then we like to draw the conclusions about the population parameter, then again confidence interval about the population parameter and the size of size of the samples. And then finally we will go for multivariate case, where we must have multiple sample case, that means it is a multiple variable case through which you have to address the business problems. So, if you go to the kind of business environment, some of the problems can be connected with the univariate structure, some of the problems can be connected with the bivariate structure, and some of the problems can be connected with the multivariate structure. So, the univariate structure which we have already discussed in the case of inferential analytics 1, and here we are going to discuss the same problems with multiple case, that is we start with the bivariate case first, then we will connect with the multivariate case. So, the highlights of the lecture is like this. We will again go by sample versus populations, then multivariate problems, and population proportions, population variance. Then again we will use all these test statistics, Z statistics, T statistics, chi-square statistics, and F statistics, and then we will connect with a case called as ANOVA and categorical data analysis, and finally we have to go for goodness fit structure. And in the meantime, in this particular lecture typically I will address the problems, the same problem through Z statistics. That means, the corresponding to inferential analytics 1, we have already discussed some of the problems connecting to Z statistics, that to comment on the population parameters, then to know the confidence interval about the population parameters, and then optimum sample size of the particular test statistics. But here it is the same case, but we are dealing with at least 2 samples. So, that means, the structure of the problem is you must have 2 populations, and you are supposed to draw 2 samples from the 2 population, and with the assumption that both the population are more or less same, and then the sample difference will find out and check with population difference, that is the population parameters kind of difference. So, here the typical structure is like this. So, there is a population 1 here typically. So, this is a population 1 and this is a population 2, and in the population 1 we are drawing a particular samples, and the corresponding sample mean is x bar, and in the population 2 we are drawing a particular sample called as x2 bar x2, and corresponding to x2 samples. So, our sample mean will be x2 bars. Now, we are drawing a sample x1 from the population 1, and again we are drawing a sample x2 from population 2, and with the assumption that the population parameter for population parameter for first one is mu1, and population parameter for second one is nothing but mu2. So, now the idea behind this particular structure is we like to check what is the difference between these 2 population parameter, and then we will draw the sample statistic, and then mean of the sample statistics, and we try to find out their difference. Now, the idea behind this particular structure is to check whether this mean of the sample difference will be converged to the mean of the mean of these 2 populations. So, with this objective we will proceed to this particular discussions. So, now corresponding to the discussion process. So, this is how the first case and this is how the second case, and by the way the difference between these 2 sample mean is nothing but called as x1 bar minus x2 bars. So, now earlier discussions we like to check the mean of the particular samples, and then mean of the population then we are checking the difference. So, here we are checking the mean of the 2 samples, and then we are comparing with the difference of the 2 populations. So, then we will like to know how is this particular structure altogether. Okay. So, with this okay, so let me show you how it can be. Okay. So, this is how the particular structure, and okay. So, corresponding to this, so this is how the particular structure. So, here the idea behind this particular structure is it is a population mean difference, that is nothing but called as mu1 minus mu2, and mu1 is the population parameter for population 1, and mu2 is the mean of the population 2. So, this is a population parameter for population 2. So, here the standard deviation is nothing but actually for 2 samples will be sigma 1 square by n 1 and sigma 2 square by n 2, and that to square root of both. And we like to check actually this is the population population mean, and this is what the sample means. We like to check what is the difference between these 2, means population mean difference and then sample mean difference, and our idea is to check whether both are same, or there is a kind of difference. If there is a kind of difference, then we like to check what is the statistical kind of difference. So, if statistically the difference is significant, then this problem can be addressed differently. If the difference is not statistically different, then we are not so we will not bother about the particular issue. But here our job is to check whether there is a difference, and if there is a difference, whether the difference is statistically significant or not, and as a result we will be dealing with hypothesis testing. It is the same structures. We have to fix the probability levels, then we have to create a confidence intervals, and then we have to see whether the calculated test statistics will be overtake the kind of tabulated test statistics, and if that is the case, then we are going to reject the true null hypothesis, otherwise we will accept the true null hypothesis. By the way, here the null hypothesis that there is no difference between these two population means, and the alternative hypothesis will be there is a difference. So, accordingly, so the corresponding structure will be like this. Okay, so, this is how the first we start with the particular structure by Z statistic, then again we will do by T statistics. So, now as per the earlier discussion in inferential analytics 1, and we can apply Z in two different situations. In one situation means in one situation your sample size should be high, that is greater than to 30, and the samples will be in the case of particular samples your population parameter sigma is given, and sometimes population parameter is not given. So, means typically in the case of Z statistic, which we have already discussed in inferential analytics 1, and that too at least your sample size should be greater than to 30, and then we have two different options. In one options your population standard deviation is given, in another situation your population standard deviation is not given. So, if it is given, then you will use and accordingly test it. If not given, then we will use sample informations as a proxy to know the sample variance, and then we will go for testing. And in this case we are dealing with the same structure, but here there are two samples, and in the both the cases we are assuming that sample size should be greater than to 30. So, that is how. So, the structure is here n 1 greater than to 30 and n 2 greater than to 30, that is the condition. And then another assumption we like to put here before this testing procedure, so they are independent. So, they are two independent samples, and then accordingly we like to check whether there is a kind of difference between the two. So, accordingly, so the Z distribution will be like this, means it is a Z statistic. Earlier we are discussing the Z statistic for one sample case is nothing but x bar minus mu divided by sigma by root n, and here the same structure, but we are restructuring with respect to two samples, and in this case instead of x bar, so it is the difference between x1 bar minus x2 bar, and here in the case of mu we are putting mu 1 minus mu 2, that is the difference between two population parameters, and then instead of sigma by root n, so we have a sigma 1 square, that is for population 1, and sigma 2 square for population 2, and the sample 1 is the first population, and the sample n 2 is the sample observation for the second populations. So, as a result, so the Z will be, it is a same structure, but it is a little bit restructures as per the particular requirement, and that too with a two sample case, where we have a two different sample means and two different population parameters and population mean, and then we have a population standard deviation. Accordingly, we are just restructuring the particular process, and then okay. So, then accordingly we will move to this particular process, and as we have already highlighted that in this particular testing procedure your null hypothesis will be mu 1 equal to mu 2, and as a result the difference between the two equal to 0. So, that means mu 1 minus mu 2 equal to 0, and alternative hypothesis will be mu 1 not equal to mu 2, and as a result the difference between these two will be not equal to 0. So, then the test procedure is almost all same. So, this is what the actually population mean difference, and then this is the sample difference, and we like to check whether the sample difference is different from the population mean difference. So, as a result the first step is to test the means fix the alpha value, and you have to target one tail or two tail. Then in this case we are putting actually two tails, so that fixing 5%, then 0.025 will come to this side and 0.025 will come to this side, and this is what actually the acceptance zones or non rejection zones. So now we like to check where is the position of our calculated value. So let us take an examples and then we will address this problem. Okay. So in the examples, so we are fixing actually as per the kind of alpha 5% and that too for two tail. So your Z critical will be 1.96, and left side it will be the value will be minus 1.96, and for the right side we will put actually 1.96. So now we have to reject H 0, means null hypothesis, if the Z calculated will overtake the Z critical. So that means it should be fall under this zones or it should be fall under this zone, right. So accordingly we have to take a decisions, and this is how the kind of confidence interval structure, and after placing the test statistics we will come to a conclusions whether there is a difference of sample means, and if there is a difference of sample means, and how this difference is actually converging towards the population mean difference, and if there is a difference and whether it is statistically different. So these are the things we are supposed to check here, and then accordingly we are addressing. So now in the for the for the sake of understanding, so we are taking two different actually data set, and this is the case of sample 1 and this is the case of sample 2, and as a result in the first case sample size is 32, that is n 1, and using all the sample points we will calculate the sample mean, that is x 1 bars, and in this case it is coming 70.7, and the corresponding sample variance is 16.253, and this is sample variance and this is standard deviations, and accordingly in the case of second samples, so the sample size is 34, so mean is 62.187, then sample variance is 166.411, and the corresponding standard deviation will be 12.9, and accordingly we will actually test the particular process. So let us go to this particular structures, and then we will see the kind of result, right. So now using the sample informations, then x 1 bar is already reported, x 2 bar is already reported, s 1 square is already reported, s 2 square is already reported, but that means previous slides we have already reported everything. Then accordingly we are just putting all these value to the Z statistics, and then we like to check the kind of results. This is the Z statistics formula, and then we are putting these values only, and after that we are getting the Z structure, Z value is nothing but called as 2.35 after simplification, and then as this is what actually called as a Z calculated. Now what will it do actually? So we like to take this Z calculated to this kind of confidence interval, and you check the position of calculated Z's, whether it is coming under the rejected zones or whether it is coming under accepted zones. Since it is coming actually 2.35, and as a result, so it will be coming in the right side, and here the Z critical is Z critical actually showing 2.33, and this value is coming 2.35. So that means it is actually more than that. So as a result, so we are in a position to reject this true null hypothesis, right. So so this is how the kind of structures we have to reject the true null hypothesis, right. So now corresponding to this, so means corresponding to this problem, so we are here to draw the conclusion that so okay. So corresponding to this problem, so we are actually finding the situation that there is a difference of the sample mean, and this sample difference is actually not converging towards population difference, and the sample mean difference and population mean difference, there is a gap, and that gap is found to be statistically significant here, and accordingly so the business decision need to be taken care of. Okay, so this is actually through Excel spreadsheet, and that we have to draw to get the kind of conclusions. So let me take you to this kind of problems, then we will highlight how this problem can be solved through actually the kind of structure. This is what actually the kind of structures, and this is this data set, and with this data set. So, what will you do? So, we will just actually calculated the kind of difference, and then with the help of this difference. So, we have to check whether it is statistically showing some kind of significant or not. The same data which we have here. So, we are actually plotting, and then we are calculating the kind of mean structures. So, what will you do actually? So, you go to this particular as data analysis, and then okay. So, this is what actually okay. So, let me take you to this particular structure. So, here actually the kind of difference, and whatever samples are here. So, what will you do? So, corresponding to these samples. So, you just report here, and if you go by manually, then you put here find out this average. So, it will be appearing average here, and again you put here average of second one, you find out the average of second ones. Okay. So, this is coming actually 62%, then corresponding to this problems, if you find here. So, it is actually 70.7 here, and then it is actually coming 62.12. So, then again you go to this data, and instead of mean, so you find out the variance. Okay. So, again you go to this particular structure and try to find out standard deviation of the series. So, it is coming 16.25, and again you find out the standard deviation of the second series, and again you find out here. So, this is what actually standard deviation of second series. Then again if you go to this samples summary, so it is actually matching. So, that means from this series you have to calculate the mean of the series, and variance of the series, and then sample size, that is n equal to 32. And again in this case, so you have to find out the mean of this particular series, variance of this particular series, and then the kind of sample size. So, now after getting all these sample size and mean and variance. So, you have to actually just put in the z, and then the z value will give you the kind of structure, the exact value. So, here there are two ways you can compare the particular results. In one case, what will you do? So, since z is coming 2.35, so now go to the z tables and find out what is the probability value for z equal to 2.35. So, that means the p value, through p value approach you can actually take the decisions. If not, then fixing alpha, and for instance here you are fixing alpha, you are getting actually means 0.5%, you are getting the z critical is 1.96. So, either you compare with z critical with z calculated, or you can fix alpha equal to some things, in this case 5%, then you find out here at z equal to 2.35 what is the probability structure. So, then you will compare whether it is coming under the rejected zones or coming under the accepted zones. So, as a result, accordingly you have to find out the kind of difference, and then the particular difference we can check whether it is means we have to take the decision whether the particular difference is coming statistically significant or not. So, now in the Excel spreadsheet, whatever information we have already gathered. So, just you have to summarize here, and this is actually the mean of this first series, and then this is what the mean of the first series, mean of the second series, variance of the first series, variance of the second series, and n1 is 32, n2 is 34. And the mean difference, we are assuming that here mu 1 equal to mu 2, and that is population 1 and population 2. So, as a result the difference will be equal to 0, and z we have already calculated, that is 2.35. Now, corresponding to z 2.35. So, you are getting actually probability level at 1 tells 0.009. So, now if you put alpha equal to 5%, then by default, so it is coming under actually a rejected zone. So, as a result, so we will come to the conclusion that there is a significant difference between these two population series, and the mean difference of the samples are not converging the population mean difference. So, as a result, so the problem need to be investigated further to get some kind of inference for the kind of as per the particular requirement. Now, again there are two typical case. If in the first case mu 1 minus mu 2 equal to 0, that is the null hypothesis, and then we are fixing alternative mu 1 less than equal to mu 2. So, as a result, so like this so we are putting first mu 1 equal to mu 2. So, as a result the difference between the two equal to 0, and in other case if not alternative by default will be mu 1 not equal to mu 2. So, now if mu 1 not equal to mu 2, then we will go by both both these sides. So, now we can go for one tail test also. In that case either we will fix actually mu 1 less than equal to mu 2, or we will fix mu 2 less than equal to mu 1. So, now if mu 1 less than to mu 2, then mu 1 minus mu 2 is less than to 0. So, as a result, so the corresponding to actually alpha 1%, then z critical will be coming actually minus 3.08. Then again we have to calculate the z value, and then we will see whether the z calculated is overtaking the z criticals or under the z kit z means that is actually critical value, whether it is crossing the z tabulated value or it is under the z tabulated value. Then accordingly we will take a decisions, right. So, this is what actually the kind of so this is the case 1 where mu 1 less than to mu 2, and then okay. So, then okay. So, so accordingly, so the problem is here. So, so in the first case when mu 1 less than to mu 2, so the same structures, but it is with a different problem, and again there are two samples, and x 1 bar is the first sample mean, and then this standard deviation is S 1s, then corresponding to sample 1, then sample 2 mean is equal to this much x 2 bar, then it is the standard deviation S 2, and sample size is 87 and sample size is 76. So, accordingly you put all these value and then report the z statistics, and now the z critical is coming actually minus 10.42, and corresponding alpha equal to 1% and 1 tail, then the z critical is coming actually minus 3.08, but here so your z value is coming minus 10.42. So, it is not actually crossing the z critical. So, as a result, so we are in a position to reject the H0. So, as a result the conclusion is to reject the H0. So, that means there is a difference, and the difference is statistically significant. Okay. So, all right. So, now in this particular structures having the kind of Z structure, so we like to highlight that there can be actually to calculate the confidence intervals. Earlier we have discussed the concept of confidence intervals. So, that is the case of one sample case. Now, we have the case of a two sample case, that to the difference. So, that means actually, so in the one sample case the structure of confidence interval will be x bar plus minus z into sigma by root n, and x plus z into sigma by root n will give you upper bound or upper critical value, and z minus x bar minus z cross sigma by root n will give you the lower bound. So, now in the same way, so here instead of x bar, so we are reporting actually x 1 bar minus x 2 bar, that is the difference between two sample mean, and then so the z sigma root n in place of z sigma root n. So, we are putting the standard error of the mean difference, that is coming z square root of S 1 square by n 1 plus S 2 square by n 2. So, again so taking this mean is the difference of the sample means and the z value, then accordingly you will find the lower bound and you will find the upper bound. So, so typically the typical means this representation will be like this. So, this is actually probability of all these confidence interval will nothing but actually called as 1.1 minus alpha, because alpha by 2 we are putting actually in the both these sides, and then we are creating a kind of confidence interval by a by the total kind of probability, that is 1 minus alpha. So, in the next slides I will show you the kind of structure. Okay. Okay. So, this is what the kind of structure, and in this case again we are taking two different samples, and the sample size this is actually sample information 1, n1 is 50 and 2 equal to 50, and x1 bar equal to coming to 21.45 and x2 bar is 24.6, then the standard deviation and the standard deviation, and then 95% confidence interval, it is coming actually 1.96. So, now what is the actually standard structure? So, you have to just find out the mean difference between the two samples, and then we have to just calculate the standard error, that is z upon square root of s1 square by n1 plus s2 square by n2. Then after putting all these value, so you are in a position to report that the confidence interval for mu1 minus mu2 will be minus 4.42 and minus 1.88, corresponding to the situation that confidence interval will be 95%. So, that means actually in this case mu1 minus mu2, that is the population mean difference, which is actually ranging between minus 4.42 to minus 1.88. So, this is actually similar to the case which we have discussed in inferential analytics 1, and here we have actually two different sample case. That is why the confidence interval will be created by taking the difference between the two samples only, and depending upon the fixing of confidence structures, we can create a confidence interval. So, that means the particular structure, what is the kind of 1 minus alpha. Okay. So, now with the what we have actually discussed in this particular inferential analytics 2. So, we are actually addressing the same issue. So, that is the comment about the population parameter by using the sample information, and then we are targeting the targeting to find out the confidence interval for the population parameter, and again targeting to find out the optimum sample size. And here the case is actually two sample case. So, that means the assumption is that there are two different samples, and they are drawing from the two different population. So, as a result there is a information about two different population information, that is the population parameters mu1 and mu2 respectively, and their corresponding standard deviation will be also given. Then with the help of population parameters, so we have to draw two samples, and then you have to find out sample statistics, and the job is to check whether the mean of these two sample statistics are converging towards the mean of these two population parameters. And accordingly we have discussed the problem through Z statistics, and at the same times we are actually we have already also discussed the concept like to create a confidence interval of this population parameter, that is the difference between the two population mean. So, by using the sample statistics, then you can create the confidence interval for these population parameters. And in the next class we will discuss the same structures by using the t distribution and or t statistic and chi-square statistic. With this we will stop here. Thank you very much. Have a nice time.